Okay po. Pa-on cam na lang ha, guys. On cam po tayo. Si everyone po, on cam po tayo. Lasap, Catalunya, Reloj, Morales, Pascual, Ramos, Billion. On cam po tayo. Billion, Reloj. Okay. Is Alemania with us?
Nandito po.
Present. Okay. Antonio? Antonio, wala po. Aquino? Wala rin. Balonan? Balonan? Ayan, si Balonan, kakapasok lang yata. Balonan, pa-on cam po, enroll yun. Naka-on cam po tayo, ha? So, Balonan, unless you turn on your cam. Okay, bawal pong mag-off cam. Billion. Wala po, Billion. Bote.
Present po.
Present po, ma'am.
Asan si Bote? Ayun. Sino yung nagpa-present? Si Billion? Nandito ba si Billion?
Nandito
Wala.
po.
Asan? Ayun. Cardona. Cardona? Wala si Cardona. Catalunya.
Present po.
Asan? Okay. Bakit buhok mo lang nakikita ko? Celestino.
Present po.
Evangelista.
Present po.
Saan yan?
Present po.
Hindi ko makita. Sorry. Ayun, okay. Gatchalian.
Present po.
Intendensya.
Present po.
Asan? Parisan nga po. Intendensya. Okay. Lasap. Lasap.
po, ma'am.
Parisan po para makita ko agad. Ayun. Limlingan.
Present po.
Okay. Makabinkil. Wala. Brian. I'm sorry.
Present po.
Mandapat, sorry. Mandapat Brian.
Present po.
Miranda.
Present po.
Morales.
Present po.
Pascual.
Present po, ma'am.
Pimentel.
Present po.
Asan
Present
po?
po, ma'am.
Marisa.
Present po. Naka-raise na po.
Okay. Ramos, Zarina.
Present
Relok? Relok? Wala. Rolyon?
Dito po, ma'am.
Rolyon?
Present po. Present po.
Rosero? Rosero? Wala po. So, marami pong absent. Meron po ba nandito na hindi natawag?
Ma'am, ako po. Sorry po.
Cardona? Natawag
Opo.
ka na. Pa-on cam po, ha?
Opo.
Relox. Sa Paris hand Relox, kung nasaan ka po. Saan to? Relox. Sakay sa tricycle. Tricycle ba yan? Meron pong hindi natawag? Wala na. Okay, good morning guys. Yan, so on cam po tayo, Miss Cardona. On cam po. Okay, ayan. So, yun. Kanina po nagklase ako, no? Yung section 3.1 ba yan? So, face-to-face po sila. Late ko din sila na replyan regarding sa kung online ba dahil no vehicle. Pero dahil nandito na daw sila sa SEA, so nagdiretso po kami ng face-to-face class. So, actually po, I prefer po talaga na face-to-face class po tayo. Okay, kasi yung umpisa po ng ating subject po ay more on magdi-discuss po tayo. And then, instead of having an online class, ang meron po tayo will be an asynchronous class. Asynchronous po siya, meaning I'll be giving you an exercise to do instead na nagkaklase tayo ng ganito. No? So, expect po ninyo na next week and next week, 2 Saturdays pa. After this Saturday ay face-to-face po muna tayo. Okay, face-to-face po tayo. And then, kung matapos natin yung dapat tapusin na i-discuss for 2 Saturdays, yan, mag-asynchronous na po tayo. Okay? So, to introduce myself po, yan, so isa po sa mga rules natin, kung mag-online class po tayo ay naka-on cam po tayo. Okay, so let me introduce myself po. Okay, so I am Engineer Bayani. Wait lang, where do I erase? Okay, so I am Engineer Bayani po. Okay, Engineer Meldanet Bayani. So I know na nakita niyo po ito, no? Na nakatag po sa SIS po niyo. So I am from the ECE department, obviously. Okay? So I'll be your professor or your teacher for this semester for fundamentals of communication. Ayan po. So just to give you a brief idea po with me as a teacher in this college po. I've been teaching since 2001 and 2023 na po ngayon. So I've been teaching for 22 years. Tama ba? For 22 years. So, di pa po kayo sinisilang ay nagtuturo na po si ma'am. So, but I only started here in QUP last 2021. Yan po. And last year, November of 2022, I was designated as the QA and the OJT coordinator of the College of Engineering. Ayan po. So, ayan. Siguro hindi ko na para isa-isahin pa kayo or magpakilala kayo, ano, dahil kilala nyo na rin naman po ang isa't isa. Siguro mas gawin na lang natin yan during our face-to-face class. So, Siguro, if you don't have any question, start na natin ang ating discussion. You have any question po? Wala naman. Okay. So guys, I hope you would be listening and magkakaroon tayo ng yes. Mr. Pascual, you're raising your hand.
Ma'am, hindi ko po alam kung sa end ko lang po, pero yung whiteboard po sa akin or yung fina-flash na po, hindi po nag-a-appear sa akin. Parang error po siya.
Sa iba po ba? Hindi rin?
Error din po.
May error din. Okay. Okay, close ko na lang yan. Okay, ito po kita po. Error pa rin ba?
Okay na po, ma'am.
Okay na.
Thank you po.
Okay, so dito muna ako mag... Okay. Kita niyo po yung naka-flash. Ano pa naka-flash? Ano naka-screen share sa inyo, guys?
Yung MS din.
Ay, MS Teams. Sorry. Okay, ayan. Okay, guys, I want you to read this muna in your mind. Miss Cardona,
Yes po.
kindly read.
Po,
Kindly read.
engineering po.
Miranda, kindly read.
Engineering.
Limlingan, kindly read.
Engineering po.
Lasap, kindly read.
Engineering po.
Balonan, naka-off cam ka, Balonan ha. Balonan, kindly read.
Engineering po.
Okay, everyone, kindly read at the count of 5. 1, 2, 3, 4, 5. Kindly read.
Engineering.
Engineering.
Okay. But guys, how do you read this? Guys, how do you read this?
Engine.
Engine. Velox, are you listening? Saan ka ba papunta?
Yes po, ma'am. Sa labas po, ma'am.
Kaya nga, ang ginagawa mo sa labas, may klase tayo.
Ang bali, po, ma'am. Pumunta po ako, ma'am, bali maaga pa po, kaya po, late ko po nabasa yung sa message, kaya nandito na po ako, ma'am.
Saan?
Bali, nakapunta na po ako sa Santa Mesa, ma'am, sa SEA po.
Sige, siguro mag-stop ka na lang muna kung nasa SEA ka na, no? Kesa naglalakad kang ganyan. Okay, guys. So how do we read this again? This portion.
Engine po.
Engine. Tama ba? Engine.
Yes po.
Okay, so therefore, how do we read the whole of this? Hello, guys.
Engineering po.
So it's engineering, no? Hindi engineering. We're not spelled as INGINNIRING, puro I. We're not spelled as engineering, no? It's engineering. Hello po. I know I'm not an English teacher, but I just want to share this with you guys. Shinare ko rin po yan kanina dun sa kabilang section. So I usually po share this with my students, lalo na kung first time po sila maging student. It was also just shared with us ng amin pong teacher sa English nung first year po. Siya po ay Doctor of English, kaya ayun. So tinuruan niya kami kung paano properly bigkasin yung ating kurso. So wag kayo nang gigigil sa pagsasabi ng kurso nyo na engineering, it's engineering. So you call your teachers engineer and not engineer. Okay, engineer rural, engineer Suliva, diba? Sino pa ba yung mga professors ninyo sa electrical engineering? So it's engineer, it's engineering, it's abbreviation naman ng engineering is like this, no? We don't write this way. This is wrong. Apostrophe R, wrong po yan, ha? Yung engineering po yung may apostrophe R. So, ayan. So, with this, guys, since kayo po ay engineering, when you hear the word engineering, what comes to your mind? Guys, what comes to your mind when you hear the word engineering? Hello po. Yes, man dapat.
Pag po na babasa ko po ang word po na engineering, ang pumapasok po agad sa akin is mathematics po.
Mathematics. What else? You can just turn on your mic and share.
Ma'am,
Yes.
when I hear the word engineering po, at the back of my mind, yung pumapasok po sa akin is, it has different field po, wherein may civil, may electrical, may mechanical, may sanitary, may industrial, and etc. po.
Okay, different fields of engineering. What else? Mag-unmute na lang po and share your answer.
Yung sa akin po, ma'am, ano po, about, ano po, pagbibuild po ng mga machines or structures po.
Build. What else?
Ma'am,
Yes.
ano po, creating something new.
Uy, create. Okay, what else?
Innovative po yung
Innovative or innovation? What else? Ano pa po? Do I have to call names? Miranda,
Core,
comes to your
core of
mind.
industry po.
Again, sorry?
Core of industry po. Parang, ano, basic core ng isang industry.
Core of industry. What else?
Making lives easier po.
Making lives easier. What else?
Designing or inventing po.
Design. Oops, so design. To invent. Okay, what else?
Problem solving po.
Problem solving.
Ma'am,
YouTube
Yeah.
ka na lang.
it's in line with mathematical analysis and and methods po.
Okay, mathematical analysis and method, no? What else?
Application po.
Application. Okay, what else?
Precision po.
Construction po.
Again? Ano po yun?
Construction po.
Construction,
Precision po.
precision. Okay. So, thank you for sharing this, no? So, guys, why am I asking you this question of what comes to your mind when you hear the word engineering? Because you're taking up engineering, right? So, do you know your direction already? Are you aware of your direction already? Are you aware of what is expected of you once you finish the course and pass the subject? Di ba may motto ang PUP mula sa'yo para sa bayan? So ano na yung i-offer nyo para sa bayan? As an engineering graduate or as an engineers already? Hello po. So guys, I'm just trying to help you, no, to realize and be more motivated and encouraged, no, to finish your course. Okay? So of course, nag-engineering tayo because we believe na magaling tayo sa math. Tama ba? Walang maglalakas loob na mag-engineering nang nahihirapan sa math. Tama ba? Hello po. May kasama ba ako, guys?
Tama po.
Ayoko ng online eh. Tama po ba yon?
Tama
Tama
po.
po.
Yes po.
So, we have this, no? We have this skills, no? And know-how, knowledge in mathematics. Okay, for us to what? For us to be able to solve a problem through mathematical analysis and methods, no? And with that, we would be able to what? We would be able to design, okay, an innovation, okay, that would have an application to what? To make life or the life of human being more convenient, tama po ba, and more comfortable, right, guys? Hello?
Yes,
Yes
po.
po.
Yes po.
And engineers, no? An electrical engineer. For you to come up po with that technology or output, no? You're going up we consider as problem. Like, ano yung gap before? Walang electricity. So, pag gabi, madilim. So, very dangerous po yun. Tama po ba? And here comes the innovation, or here comes the discovery of electricity, right, guys?
Yes po.
Yes po.
So, your major is electrical engineering. So, what's with electrical? What's with electrical? What are you really supposed to study?
Electricity po.
About electricity? Ano to? Para on-off lang ni electricity? On-off lang ba to ni electricity?
Ano po, yung parang yung concept po kung paano po magpapagana ng mga example po yung mga appliances po natin sa bahay para po magpagana po and using the flow of electrons po, which is electricity din po.
Yeah, mapagana. Nabanggit mo yung flow of
Electrons po.
electrons, yes. Electricity is actually the result of the flow of electrons, right? Right, guys? Electricity,
Yes,
again, is a result of the flow of electrons. Controlling the flow of electrons will result into electricity. So therefore, as an electrical engineering student, so what is expected of you? So what is expected of you guys? For you to be able to bridge the gap for you to be able to resolve a problem, no? That concerns about flow of current resulting into electricity. Like, ito yung no matter how high-end the technology is, wala pa rin talagang engineer na makakapagsabi na pwedeng i-transmit through air ang electricity. Tama ba? San Goku lang ba yung kayang gumawa nun? Pero malay nyo, no? Kaya nga tayo may subject na thesis, guys, diba? Kaya kayo may subject na thesis, no? Is for you to somehow as an earliest of age nyo ngayon, you would have an idea or you would be able to think of, okay, what possible contribution you can actually have or you can actually give to our country after you finished your course and passed the board exam. I hope, guys, somehow this gives you the direction. Okay, hindi yung basta lang tayo pumapasok. Dapat alam natin kung ano yung expectations sa inyo as an electrical engineer. You are not bounded into electricity alone. Okay, you can do collaboration with other fields of engineering. Like yesterday, we have this recite event where the speaker was is a professor from the De La Salle University, and he's having a research study on e-vehicle. An e-vehicle is powered by e-vehicle is powered by
Electricity po.
electricity.
Electricity po.
So from here we can see, no, this is a collaboration of mechanical engineering and electrical engineering, right? And can also be a collaboration of EE, ME, ECE, CPE. Tama po ba? If the control would be really computerized and electronically operated then. Kumbaga by electronics yung ano natin, pag-control, no? Though it is powered by electricity through charging. Hello po? So ano yung binibridge na gap? Ano sa tingin nyo yung na-try na i-bridge na gap with the invention of e-vehicle? What is that gap that is being bridged? Or what is that problem that is being tried to resolve with the invention of e-vehicle?
Lesson
Pollution. Carbon emission, yes. No? That's the solve itong electric vehicle na to. Kaya lang as of now, kaya nga po siya naging study, no, naging topic for study of Professor Lopez from De La Salle University because e-vehicles are too expensive. No, meron pong and different car companies would have different technology in manufacturing their e-vehicle. And there would be a brand na for a year isang e-vehicle lang yung nabebenta because again it's too expensive. If nabalitaan nyo guys yung sa mga e-jeep, 'di ba, yung kasi pinapa-phase out na yung mga jeep lalo na kung bulok na ito. 'Di ba, yung tipong pag nalubak maghihiwalay na talaga yung mga tornilyo ng mga piyesa nito, kasukasuan. So kaya nagkaroon ng e-jeep through ano ba to, yung mga cooperatives, diba, around 2.2 million. And 1 million of that 2.2 million is for the battery. Imagine how expensive the battery is. Because that's the part of the vehicle that powers up, no? The vehicle itself. So it's very expensive. So ang concept natin ngayon is how can we make this more affordable? So yung design niyan, nasa sa inyo na yan, nasa sa EE, nasa sa ME, energy. Energy ang pinag-uusapan natin dito. 'Di ba? Hello guys. Ang naging reklamo dun sa Egypt na yun, wala pang isang taon. Hindi na nagagamit. Nasira yung battery. Ba't nga ba nasira yung battery? Dahil kulang sa information. Si cooperative naman, hindi naman kasi sila technical people, so basta lang sila nagbenta. Okay, without the information na yung battery na yan should not be operated beyond 35 degrees Celsius. So therefore, alam naman natin, mainit ito sa Pinas, tapos ano talaga, 1 to sawa ang biyahe, init po talaga yung ating battery, right? So nag-ooperate po yung Egypt at more than 35 degrees Celsius. So nasira po yung battery. So hindi na po napakinabangan, kaya mas lalong hindi na nag-boom yung utilization ng e-vehicle or e-jeep. But then again, it should not stop from there. May problem. Tama po ba? May problem? May problem ba doon? Okay, so as an electrical engineer, so how are you going to solve that problem? Ay, hindi ko kayo hiningin ng sagot ngayon, ano? Ang akin lang is, I'm just trying to trigger, kinikiliti ko lang po yung brain cells ninyo. So, ma-excite po ang bawat isa, makagraduate at makapasa ng board exam. And to do things na makakapag-deliver kayo of something that is useful for human being. Diba sabi nyo, mula sa iyo para sa bayan. So ang tanong ko, ano nga ba yung hinahanda ninyo, guys, as an electrical engineer para sa bayan? Ano nga bang isusukli ng isang scholar ng bayan pagka-graduate at pagkapasa niya ng board exam sa bayan na nagpaaral sa kanya bilang electrical engineer? Are you getting my point? Guys?
Yes po.
Yes
I hope with this, mas naisip po ninyo, ano nga ba yung direction na tatahakin ninyo? So I'm not so familiar with the fields, with different fields of EE. So but I believe hindi lang kayo para lahat magsiksikan sa Meralco. Okay, sa sobrang dami ng EE students, hindi lang po sa PUP kundi sa iba't ibang school. So hindi kayo kakasya lahat sa Meralco. Okay? So this is how I introduce my class. First is to share with you how we properly pronounce our course. It's engineering, it's not engineering. And for you to somehow understand what is expected of you as an electrical engineer. Okay? So just raise your hand, guys, if medyo mabilis si ma'am. Ayan. So mas maganda yung naging klase namin kanina na face-to-face. Iba talaga yung energy kapag face-to-face yung klase, no? Okay? So anyway, for our next so let's since our subject is fundamentals of communication, my question is this: how do you understand communication, guys? How do you understand communication?
There's sender and receiver for that process information po.
Again, sorry?
Communication po, meron po siyang sender and receiver na nagpa-process po ng information at nag-share po ng ideas po from 2 or more location po. Or points.
Pimentel? Sorry. Sino yung nagsasalita po?
Ako po, no.
Si Pimentel. Ayan, okay. Ayan, naka-view na ako ng speaker. Okay, thank you. Sino pa po ang may gustong i-share? Alemanya?
Para sa akin,
You're raising your hand, Alemanya.
para sa akin po yung communication po is interaction through a medium po.
Interaction through a medium. What else? Sino pa ba? Nag-raise ng hand. Mandapat.
Para sa akin po, yung definition po ng communication is pagpasa po or pag-relay ng message.
Exchange of, message or information. Meron pa po bang idadagdag, Ramon?
Connect people po. It helps us connect people.
It's a means of connecting people. Pa-on-cam po, Ms. Ramos, ha? Okay, Pascual?
For me po, yung communication is exchanging information. There must be a sender and there must be a sender to make the to for communication take place po.
Okay. So, sa lahat ng sinabi, we will all agree that communication is exchange of information. May transmitter, may nag-transmit, may nagre-receive, and between the transmitter and the receiver, meron tayong channel or medium na kung saan dadaan yung information na yun. So, information is a process data. Data doesn't have any meaning, so unless it is being processed, so that's why before we can call it as an information. Now, do you believe, guys, that distance is a barrier for communication? Distance is one of the barrier in communication. You believe that, guys?
Can you repeat the question po, ma'am?
Do you believe that distance serves as one of the main barriers in communication?
Yes po, ma'am.
Yes, no. Do you think having known that distance is a barrier to communication, do you think it's already resolved at the present time? Is this
Hindi pa po.
barrier of distance already resolved?
Hindi pa po siya
Somehow po.
completely resolved. Ganun po.
Again, sorry, Miss Miranda.
Hindi po siya completely resolved but nasa process na po siya. Kasi po, di ba, may internet na po.
May internet na. Yes. So, sa tingin mo, ano pa? Sabi mo, hindi pa siya completely resolved. Ano yung nakikita mo na kulang pa?
Yung yung connectivity, yung mga connection po, minsan, di ba po, kapag malayuan, na meron pa rin pong possibilities na mahina po yung signal or mga power interruption or internet interruption. So,
More on the technical side, no? Of being able to transmit and receive signal na walang mga distortion or interferences. Okay? Pero guys, what you have now is malayong-malayo na yan sa meron kami before. No? Wala naman talaga kaming internet, no? Way back when I was still studying 1990s. So wala talaga kaming internet. So the barrier, no, the distance as a barrier is really a very big barrier. Yung mga live streaming before, mga 30 minutes yung delay time niya, no, kaya 1 hour yung delay time. Halimbawa, may laban ng basketball, katulad kagabi, mga championship na ganyan. Okay. Hindi namin yan na papanood ng kumbaga as is, no, real time. Kumbaga kung magmamine ka, wala. Hindi mo mamamine yung naka-online kasi delayed telecast. So, but what you have right now, di ba? Talagang talagang synchronized. Nagkaka-problem lang as mentioned, no? Depende sa distance, depende sa provider. Ayan na. So, meron pa rin mga constraints. But somehow we can say that the distance as the barrier has been resolved. Kailangan na lang talaga ng enhancement pa. Right? It's being resolved, i-enhance na lang, i-develop na lang para talagang mas maging maayos po. May klase ako. Ayan po. So, ayun. So, for enhancement, for further enhancement, innovation, and development. Okay. So, ano pa ba yung sa tingin nyo guys sa barrier? Another barrier of communication or in communication. Another barrier.
Hello po, ma'am.
Yes, yes.
I think another barrier po is yung availability po ng mga appliances. Example,
Yeah. So, ito naman ay kumbaga, etong barrier na to is more on resources ang pinag-uusapan. Tama? Pero, okay. Tama naman yon. Pero, yung idea po ba na ito yung barrier na natural na barrier. Like distance, it's a natural barrier. No, na kumbaga parang nung mauso ang exchange of information, talagang nandiyan na yung barrier na yan. Okay, ako na lang magbibigay, no, para hindi tayo maano ng oras. So, another barrier is language. You agree with that, guys? Language? Okay. So, when I was teaching 2009 po, no, sa FEU as a part-time faculty din po sa before, no, sa FEU. Kaya may estudyante po akong Chinese. So, meron silang device na parang, ano yan, interpreter, something like that. Pero itinatype pa nila. No, itatype nila, halimbawa, nagsulat ka sa board ng English, itatype pa nila yan para i-convert, i-translate. It takes time. Diba? It will take time. Barrier yun. Barrier na yung language. Tapos, as a natural thing, barrier pa yung device niya kasi mabagal. Diba? So, is it being resolved now? Yes, no? Google Translate. Tama ba? Somehow, ano lang, ready, basta may internet ka lang. Diba? So, by voice, ayan. So, matatranslate naman siya, may not be as accurate as what is being said, pero using your logic, at paano magkakaintindihan kayo. Tama po ba yun? Okay? So, what we're trying to say here, these two main barriers, language and distance, has already been resolved. It's just a matter of innovating pa. No? Tama ba? Enhancing the equipment, enhancing the manner, enhancing the technology. But these two main barriers have already been bridged. No? Patitibayin na lang yung bridge na sinasabi natin siya. Okay. So guys, I'll be sharing na po our lecture na. Okay, kita po yung naka-share.
Yes po.
Okay. So by the way guys, no, so pag sinabi nating electricity, again, it's because there's a movement, no? Electricity is the result of the movement of electrons, and electronic communication was made possible because of being able to manipulate the movement of these electrons. Then therefore, the original information, yung voice, audio, video, symbols, letters, and all, are all converted electronically for it to be able to reach, no, further distances. So communication again is the process of exchanging information, and again, main barriers would be language and distance. And meron tayong tinatawag na contemporary society's emphasis or contemporary society. So it pertains to what is uso now. Ano na nga ba yung uso sa era nyo ngayon, 'di ba? So pag inisa-isa natin yan, sobrang madami yan. But what we're trying to say here is that the term contemporary, okay? What is considered contemporary today or yung uso today will become history in the future. So walang uso na tumatagal for life. Except for ligo, no? Usong maligo. Kaya kahit malamig, uso pa rin pong maligo. Ayan. So again, it encompasses the ways in which people interact, organize themselves, and live their lives in the current era. So we have these methods of communication face-to-face. Yun dapat yung meron tayo ngayon, no? Face-to-face. And then we have signals. Ito po yung mga symbols. Halimbawa, road symbols po para sa mga driver, sa mga nagda-drive. And ano pa ba? Para sa mga deaf, no? Ang method of communication nila is through sign languages, right? Ayan po. Written words, yes, is another method of communication, letters. Kaya lang, parang, ito sa atin, hindi na written word or letters, kundi through chat. No? Chat through internet. Ayan. Before po, of course, nung time ko po ay wala pa po naman talagang internet. So how do we how do we communicate, no, with the friends like that? So snail mail talaga. So yellow pad, stationery, ganyan. Tapos papadala talaga through snail mail doon sa post office. Tapos kaya siguro nasunog na yung post office na wala na nagpapadala ng mga letters. Ngayon po, pag nag-apply ng trabaho through internet na lang, online application, tama? Nung time po namin, talagang in-email po namin yung aming resume, aming photocopy ng transcript of records and all. So, naka-ano po yan, naka-registered mail. Naka-registered mail po yan. Okay? And ditimbang, no? And it will reach the company mga 2 to 3 days. 39 to 3 days, maximum of 5 days pag malayo-layo po yung company na applyan. Unlike ngayon, diba, just click send and it's there. Depende na lang kung babasahin agad nung employer. Okay? And then we have these electrical innovations, telegraph, telephone, radio, television, and internet. So again, electronic communication refers to the sending, reception, and processing of information by electrical means. And information source would be symbols from an alphabet or of possible symbols. And we have these different types of communication system where information can be obtained. So we have radio, telephony, telegraph, broadcasting, radar, telemetry, and radio aids for navigation. So again, electronic communication system, okay, its main purpose is to communicate information between two or more locations commonly called stations. Guys, can you give me an example, or what do you think is that example of exchange of information where there is one source, but there are many receivers? One source of the information, but many receiving stations.
Television po, ma'am.
Yeah, that's television broadcasting. So broadcasting in general, whether that's television or radio broadcasting. So broadcasting in general, from the idea broad, cast, parang ikakalat, ganyan. So broadcasting, it's a one-way communication, no? It's a one-way communication. And this is done by converting the original information into electromagnetic energy and then transmitting it to one or more receive stations where it is converted back to its original form. Okay, if we're going to look into television broadcasting, no, of course, what is being sent by the transmitting station is a converted signal already. So naka-electromagnetic signal na po yan, or energy, that will travel through the air or through the atmosphere and will be received by our, before antenna pa po eh, ngayon mga digibox na, no? And then, it will be converted back, no? Converted back into the signal na, what you call this, that can be understood by the user. So yung video, yung audio, yung music, everything is converted into electromagnetic energy. And then once received by the station, receiving station, so it will be converted back. Hindi yung picture hindi yung picture directly binabato sa atmosphere. And then pag tumingin ka, makita mo yung picture lumilipad. O kaya yung mga artista lumilipad sa ere kasi i-receive ng mga TV, walang ganon. So everything is converted, no? There is a conversion of energy, one form of energy to another, or one form of signal to another. Okay? So, ang next na po natin ay history. So, we have 6 slides po for the history. I will not dwell po. I will not dwell on this history kasi alam ko na boring po ito sa inyo. So, this will just end up as your activity. Team activity naman ito, guys. Don't worry. I'll ask you to form a team later. So for our next slide, wait lang po, guys, ha. Ayaw na naman mag-show ng picture. Wait lang po. Wait lang, guys, ha. Naglolo ko po yung PowerPoint. Ayaw ipakita yung, mga pictures. Wait lang. Okay, kita po natin. Okay, guys, so what we have here, so what I'm presenting is what we call the electromagnetic spectrum. Okay, so this serves as the highway of different information or different signal for different purposes. Diba? For different purposes, may kita natin later. So, bakit ko nasabing highway? Imagine niyo guys yung expressway or any kalsada na dinadaanan ng sasakyan nang walang identification kung saang area or saan dadaan yung papunta sa south at kung saan dadaan yung papunta sa north. Are you with me, guys? Kung walang distinction, basta bukas lang yung kalsada na yan, bahala kayo kung paano kayo dadaan dyan. Okay ba yon? Okay ba yun, guys? Siyempre, malaking disgrasya mangyayari dyan. Tama po? Yes. Okay.
Yes po.
Yeah, ganun din po ang ating electromagnetic spectrum, which is a natural resource. Okay? No person, no great mathematician were able to create this. Wala po. These were made readily available to us by our God. So this is a natural resource na na-discover. Okay? It was just discovered. That's why it's being utilized nowadays. So ito po, each of this range serves as a road or kalsada or channel where this signals will be passing through according to its application. So from 3 Hertz to 300 gigahertz. So tingnan po natin. So let's start with extremely low frequency, which have three sub-band. Okay, so we have we have here 3 hertz to 3 kilohertz. We have this sub-band. Okay, so ELF from 3 to 330 hertz, and then super low frequency 30 hertz to 300 hertz, and then ultra low frequency 300 hertz to 3 kilohertz, guys. By the way, this is according to IEEE. This is Institute of Electrical and Electronics Engineering band designation. Okay. This range is highly vulnerable to disturbance and easily distorted by atmospheric changes. And designing a system in this range is challenging because the larger wavelengths require long antennas, which are practically impossible to achieve. Ano po ang ibig sabihin nito? Wavelength pertains to this or symbolized by lambda, and is equal to the speed of light over frequency. So kung extremely low frequency tayo guys, 3 hertz, mababa, so mataas po yung ating wavelength. I don't know kung familiar pa po kayo sa antenna. Okay, yun po yung mga nakikita natin sa bubong na may mga ganyan-ganyan. Okay, so bakit sinabi na challenging? Because the larger the wavelength, mas mababa yung frequency, mas mahaba yung wavelength, mas mahaba po yung element. Ito po, element po tawag natin dyan. And this element is being designated as the channel. Halimbawa, ito, channel 2, channel 7. So, bawat channel may isang element. Ilan na yung channel na meron po tayo, di ba? Kaya nga nauso na po yung cable. No? Kasi nga po, si antenna, pag-construct ng antenna, habang pataas ang frequency natin, paliit po yung wavelength natin. So, therefore, yung element, paliit. No? And it would be very impractical to have that. So, engineers, pulit yan, di ba? So, bridge the gap of complicated or complex design of antenna instead of still having this antenna with numbers or different types of elements. So, nag-come up with cable TV system or digital TV. Ayan po. So, that's with extremely low frequency. I hope you're listening, guys. Next po. Next, we have the very low frequency. So, it's a starting range of RF and practical radio transmission, which spans from 3 kHz to 30 kHz. So, the design and implementation of the antenna system are extremely complicated, again, still, due to the wavelength and the radio stations, using in time radio stations, which synchronizes clock signals between two remote locations. Then we have the low frequency. One of the, 30 kilohertz. Kung mapapansin natin, lagi nag-start lang naman sa 3, ano? 30 kilohertz to 300 kilohertz. Okay, one of the important properties of low frequency signals is that they will get reflected by Earth's ionosphere. Nasa ba yung ionosphere? Nasa taas, nasa baba. Nasa taas, diba? Okay, so if this is the antenna po, so that will be reflected by the ionosphere. So longer distance yung mata-travel. At this is sabi natin that the distance has been being bridged as one of the barrier in communication. So we have amateur radio operators, okay, RFID tags, submarines. Okay guys, ano lang to ha, since introduction tayo today, overview, so medyo in passing po yung discussion ni ma'am. Pero we will go into each of this into details as we move along with our discussion, no? Kaya ayoko po ng online talaga kasi, ayan, katulad yan, may mga nakasandal at nasa kama, mamaya tulog na yan eh. Ayan, nasa biyahe, yan, nakakaantok, imbis na, di ba, na pay attention tayo. Okay, so anyway, ano ba yung RFID? Ang example nito ay beep card. So, familiar kayo sa beep card, tama po ba? Ayan. So, meron pong reader, di ba? Merong reader doon sa LRT, ganyan. Tapos may turnstile. Turnstile yung tawag natin dyan eh. So, ito-tap nyo yung ID nyo dyan. So, yung beep card kasi, ang card na yan ay merong loop antenna na naka-embed sa loob. So, that is a passive antenna. So, kapag tinapat natin dito, mababasa ng reader natin. Because each of this ID ay may serial serial number po yan. So, unique po yung ID na yan. Kaya po, na-identify kung magkano yung laman. Okay? Kasi, di ba, pag nagpapaload tayo, ano ba yun? Parang itatap din natin yan kung doon tayo sa station. Pero pag sa cashier mismo, tinatap din, ano? Tama ba? Okay, para malaman talaga, ma-read ng system yung serial number ng bit card para doon po yung load. Kaya nababasa po ng system natin dito. Okay, kung ano po yung, magkano yung laman, no? Ng bit card na yan. And you cannot use your bit card to other RFID or reader. Tama? Kasi po, itong reader na to is so designed only to read, no? Yung frequency ng loop antenna sa bit card. Okay, kumbaga parang partner po talaga yan. I don't know if you're ano po, naka-observe na sa mga company. Kasi wala tayong turnstile no? So hindi ko alam kung yung ID po ninyo or yung ID natin ay RFID. So sa ibang school and sa mga company, they use RFID, okay, to get inside the school or to get inside the company premise and to get out also. Kasi sa mga company po, yung technology na yan, ginagamit na rin yan for attendance purposes. First in, last out. Okay, so si bip card, di natin pwedeng gamitin doon, no? Para makapasok tayo sa kung saan man. Nakuha po ba natin, guys? Hello po. Kasi iba po yung program, no? Na has been utilized for that use. May magtatanong po ba? You can raise your hand if you want to ask something, ano po. Okay, so that's with low frequency. Next, we have the high frequency, so also known as a short wave. So si low frequency natin is ground wave. Si high frequency naman natin ay kanina, tumalan ba ako? Nasa low frequency, okay. So ground wave po si low frequency. Okay, next one is medium frequency. So kung makikita po natin, nandito po, beginning of wireless transmission, radio transmission, kasi dyan po nag-start yung AM radio. So yung AM natin, yung signals natin sa AM radio ay within the medium frequency, 300 kilohertz to 3 megahertz. So these are the other applications of medium frequency. Next, we have the high frequency. So if low frequency is known as ground wave, ito naman si high frequency is known as short wave. It is one of the suitable bands for long distance communication. Mainly used for aviation industry. Okay, so when you say aviation, ito yung mga sasakyang panghimpapawid. Ayan. Near-field communication, government system, amateur radio operators, and weather broadcasting stations. Next is we have the very high frequency. Yan, guys. Nung kapanahunan ko po, ang TV ay VHF pa lang. Kasi ilan lang yung channel. Channel 2, Channel 4, Channel 7, Channel 9, Channel 13. Yan lang po ang channel nung ako po ay elementary. So, VHF po yun. Okay, ngayon po, napakarami na pong channels and that was made possible because of cable or digital TV system. Ayan. So, this is for air traffic controllers, airline pilots to communicate, no? Other uses include private business radio stations, medical equipment, no? Yung magnetic resonance imaging natin, yung MRI. So, you see guys, sabi ginagamit sa medical equipment. So, what I'm trying to say, of course, iba yung expertise ng mga medical people. Diba? But, ang gumagawa po ng mga equipment nila, mga devices nila, ay mga engineers. Diba? Hello po. Hindi naman nila kayang mag-design, mag-construct, but tayo as engineers, ang makukuha natin sa kanila is the concept. Ano ba yung gusto nilang machine? Ano yung nagagawa ng machine? So, ano yung input? Ano yung output? So, given the specification or requirements nila, So we would be able to come up with their medical equipment. So an example of that is magnetic resonance imaging. So nagkakaroon talaga guys ng collaboration with different fields. Kasi nga, yun nga po, one expertise needed by another expertise. No? So kaya collaboration is really very important. Next, we have the ultra high frequency. So here, ayan. So most critical frequency ang sabi. It begins from 300 megahertz to 3 gigahertz. Ayan, GPS navigation system, satellites, Wi-Fi, Bluetooth television broadcasting. Ito po. Ito na po yung sa ating internet, no? Next is we have the super high frequency. Ayan na po, no? Nasa gigahertz na po tayo, times 10 raised to 9. Okay, so digital TV, ito na. Kaya marami na po tayong channels, no? And that's why hindi na kailangan ng antenna. Coaxial cable or fiber optics na po, ginagamit natin. So we have Wi-Fi, 5 gigahertz channels, microwave oven, mobile network, RF cables, diba? Ayan, so system design is extremely hard in the super high frequency band due to its smaller wavelength and complexity. Again, wavelength is equal to the speed of light over frequency. So imagine nyo, 3 gigahertz. So ito yung maging times 10 raised to negative 9. So nano. Nano yung wavelength natin. Next is we have the extremely high frequency. Okay, so highest in the RF frequency spectrum, which ranges between 30 gigahertz to 300 gigahertz. Only used in advanced communication systems due to its complex nature and line of sight requirement. Pag sinabing line of sight, guys, halimbawa, ito po yung antenna, ganyan yung bato, line of sight. Eh, ma'am, paano kung merong dyan, bundok, building? So, hindi natin bubutasin yung bundok or yung building para magkaroon sila ng line of sight. Ano magkakaroon? Magkakaroon ng panibagong station dito, tawag natin dito, repeater, ibabato niya muna dito, tapos, kumbaga, paikutin doon sa obstruction. Okay? So, EHF is used in radio astronomy and remote sensing or weather analysis due to large bandwidth availability, and it is suggested to use high-speed internet systems like 5G technology. And we have this tremendously high frequency above 300 gigahertz used for medical applications, x-rays, spectroscopy applications, and supercomputers. So guys, yung electromagnetic spectrum natin is considered finite. Hindi siya nauubos, pero pwedeng makonsume na lahat yung channel. Kumbaga parang wala nang ibang kalsada na pwedeng daanan yung sasakyan. Nakukuha po ba natin? Each of the bands or each of yung range could be maximally utilized already or utilized in its maximum level already. Though hindi natin alam, no? Kasi sabi dito, tremendously high frequency above 300 gigahertz. So hindi natin alam kung sino pong mga future engineers yung mga ka-discover na, okay, meron pa palang mas mataas pa talaga sa 300 gigahertz and will be used, no? Or can be used for a particular application. Malay nyo, next na dito, teleporting na. Diba? So, mauso na yung teleporting. O kaya naman, guys, kayo yung kayo yung come up into transmitting electricity through air. Wireless transmission of 200 kilovolts. Ayan. Pwede ba yon, guys? Hello? Nakaka-relate po ba kayo? Are you listening? Tingin nyo ba, guys? Tingin nyo, pwede nga ba? Malay nyo naman, as you go along with your major subjects, no, ma-realize nyo or magawa nyo ng paraan may transmit through air ang electricity. Kasi lahat natatransmit na eh. Except for, ano na lang ang hindi kayang i-transmit through the atmosphere? Electricity and water. Tama ba? Electricity cannot be converted into an electromagnetic signal as well as water. And so as food, di rin. Mag-order siguro para for delivery ng food pwede, no? Pero yung food para i-convert into electromagnetic signals and to be transmitted through air ay hindi po possible. So guys, here is a colorful explanation or showing you guys a colorful way of the electromagnetic spectrum or radio frequency spectrum with its usage. Again, from ELF to EHF. So what are the basic elements of and components of communication system? So we have transmitter, channel or medium, receiver, and noise. So you may be wondering, bakit may noise? Diba? Bakit may noise? Bakit kasama siya sa elements and components? Okay, because if we're not going to, what is noise ba? This is an electrical disturbance. No, this is a disturbance in electric form that results into distortion or distracted signal. And pumapasok po yan during the transmission of the signal. So, bakit nga siya part? Para pag dinesign natin yung transmitter and yung receiver, nako-consider natin yung possible noise that can be encountered. And ma-adjust natin yung system natin, ma-adjust natin yung design natin sa transmitter such that hindi siya maging ganun ka-vulnerable sa noise once ibato na natin yung signal. By the way, guys, paano mo naman malalaman kung ano yung noise? Okay? Katulad ng electromagnetic spectrum, guys, if each spectrum or if each range has a particular use, si noise po, meron din siyang range of frequency. Merong noise na pang ELF, pang VLF, pang LF, hanggang pang EHF. Nakuha po natin, guys. So, yung noise kay ELF ay hindi noise kay EHF. Yung noise kay EHF ay hindi noise kay ELF. Are you with me? Are you with me, guys? So, pag magde-design tayo ng communication system, so dapat, alam talaga natin yung band of frequency na gagamitin natin para pati yung noise ma-identify natin. And actually, yan yung next topic natin next week, noise. And there would be noise computation. Sabi nga natin, kasama yan sa part ng design ng communication system. Okay, so this is the basic block diagram, no, guys? Ito yung sinasabi natin. So, yung information, process data, or intelligence. So, yan yun, no? In analog form. Okay, so si transmitter, ipaprocess niya yan. Tapos lalabas siya dito into a form of signal that is suitable for the medium, whether it's wired or wireless. So itatransmit yan either, yun nga po, wired or wireless. Kung wireless, so may antenna tayo. So kung receiver, may antenna rin tayo. Kung wireless po yan. Kung wired, so be it. So nakita po natin, meron po tayong noise. Okay. So what is a transmitter nga po ba? What is a transmitter? A transmitter is a composition of electronic components. Okay? That processes the information, converts the information into a signal suitable to the channel. While the receiver is the same thing. It's a composition of electronic components, equipment, devices. Okay, that would be capable of receiving this information from the channel and convert it back into a signal that can be understood by the human being, by the machine, or in short, that can be understood by the user. Some question, what is made up of transmitter? So, si transmitter, of course, an example, a very basic example is microphone, sound system. So, may microphone tayo. Okay, so si microphone is a transducer, converts an energy, one form of energy to another. Diba? Dito ay voice. Guys, hello po. Hello po. Are you still listening, guys?
Yes po.
Yes po.
Okay. So si voice, i-convert yan. So marireceive yan ni microphone. Si microphone po, yung basic example po ng microphone is using a carbon granule. So, may diaphragm po dito. Ito yung carbon granules. So, ito ngayon, si voice, kasi guys, no, kung face-to-face po tayo, yung naririnig yun na voice sa akin is not really coming from the inside of me. But what is coming out of me is just an air, no, na in-release ko with application of pressure from my diaphragm. And that sound that you are hearing from me is actually because of the movement of the molecular structure, yung vibration niya. Kasi, an example of this, guys, pag, di ba, I don't know kung na-try nyo maglaro ng tubig sa balde o sa planggana, pag naghulog po kayo ng anything sa gitna, di ba, nagkakaroon ng parang wave yung water? Na-destruct kasi yung ano niya, molecular form. Na-try nyo ba yon, guys? Naiintindihan po ba yung sinasabi ni ma'am? So, ganun din po yun sa molecular structure ng air. So, pag merong air pressure na in-exert po tayo dito sa molecular structure na to, so magkakaroon niya ng vibration. That vibration, okay, that vibration causes the sound that you can hear. So, yung vibration na yon, ito po yon. Yung vibration na yan, tatama yan sa carbon granules, tatama po siya doon sa diaphragm. And sa bawat tama niya po sa diaphragm, ay meron siyang corresponding na electrical signal. Hindi naman po talaga sound wave or voice signal ay sinusoidal, no? Representation type of wave po yung sine wave, cosine, ganyan. So, electrical signal. Okay? Tapos ipaprocess yan, di ba? Meron tayong amplifier, equalizer, di ba, guys? Tapos, ano natin maririnig yan? Meron tayong speaker. Si speaker ay transducer din. Converts electrical signal into audio naman. Are you with me, guys? So, converting into its original form. Kaya lang dito, guys, no? Napakasimple nung way of conversion of the original signal to an electrical signal into back to its original form. Sa ganito po, sa exchange of communication, at distance po ang pinag-usapan natin, either wired or wireless. So meron po tayo kay transmitter, meron po tayong oscillator. Okay? So ano po si oscillator? An oscillator is an electronic equipment or circuit, guys, that is capable of providing output even without an input. Imagine providing an output even without an input. That is utilizing positive feedback. Kasi po, ang electronic circuits, guys, meron po yung DC bias para mag-power up yung mga components, diodes, transistors, may DC bias po yan. Okay, so dahil may DC bias tayo, so magkakaroon ng heat energy, may formation ng heat energy sa loob. Tama ba? Okay, and that heat energy ay mag-serve as an output. Okay, i-feedback sa ating circuit at dahil positive feedback yan, ibig sabihin, mag-add up. Ibabalik po ulit dito, mag-add up ulit. Until such time na yung i-release ng oscillator natin is a signal of constant amplitude and constant frequency. Para saan po yung signal na pinoproduce ni oscillator? Yan po yung tinatawag natin na carrier signal. Okay? Yan po yung tinatawag natin na carrier signal. From the word itself, carrier, siya yung magkikarry, siya yung magdadala ng information natin papunta dun sa receiver. Nakukuha po ba natin? And this carrier has higher frequency. No, yung carrier signal natin, yung modulating signal natin, this has a higher frequency than the modulating signal. So ano yung modulating signal? Yan po yung ating original signal. Marami tayong tawag dyan, modulating signal, information signal, or intelligent signal. Okay? So mas mataas po ang frequency niyan. Kumbaga guys, kung pupunta tayo ng Baguio, sa ngayon ba guys, pag pupunta kayo ng Baguio, maglalakad kayo? Magbabike ba kayo? Ano sasakyan ninyo? A vehicle that would bring you faster. Tama? Doon sa Baguio, no? Dati talaga wala namang hindi ganun pakabibilis talaga yung means of transportation. Pero, what I'm saying is, kumbaga sa tao, merong sinasakyan yung ating mga information para makatarating sila doon sa kanilang destination. Diba? Tayo, sasakay tayo ng bus, pupunta tayong Baguio. Dadaan ngayon yung bus sa highway. Tama po ba? O, tapos makakarating tayo ng Baguio. O, nandun na tayo sa Baguio, nandun na tayo sa receiving end. So, ganun din po yung ating information. Sasakay siya kay carrier, dadaan siya dun sa channel or medium, whether that's coaxial cable, fiber optic, or through the atmosphere. Okay, and then it will be received. Now, after yung oscillator, dito pa lang tayo, no? Sasakay pa lang po si ating information. Meron po tayong tinatawag na amplifier. Anong ginagawa ni amplifier, guys? You don't answer me amplifies the signal. We don't define a term by term. Parang pag tinanong ko, so what do you mean by resistance? Resistance, resist. So, hindi gano'n, no? So, when we define resistance, it pertains to the limitation to the flow of current. Tama po ba? It limits the flow of current. So, si amplifier, hindi amplify. Okay, though, galing siya sa root word na, yung idea ng amp, no? Because signal would have three parameters. You have amplitude, you have amplitude, frequency, and phase. The amplifier, another term for amplifier is relative strength. Relative strength. So, si amplifier, therefore, increases the relative strength of the signal. Halimbawa, ito yung amplifier natin, ito yung signal natin, in-amplify. Diba? Ang tataas yung amplitude. Nakukuha po ba? It's the relative strength of the signal that is being increased, not the frequency, not the phase. Parang tayo lang yan, guys. Pagkatapos itong klase natin, di ba, pagod na tayo? O dapat nag-early lunch kayo. Diba? O yung mga naka-off cam dyan, malamang nagla-lunch na yan, humumuya na. Kasi napagod na. Ganun din po yung signal. Diba si oscillator, pasasakayin niya na si original signal sa kanya. So nagkaroon na ng processing. Napagod na yon. So kailangan i-amplify. Ba't kailangan i-amplify? Kasi dadaan pa siya sa tune circuit, etc. Para makadaan siya sa channel. Okay? So, meron tayong tune circuit. Ano yung tune circuit, guys? Is mga EE students. Components yun po ito. These are components whose function is relevant to frequency. What is that component whose function is relevant to frequency? O, sasagutin ko na rin yung sarili kong tanong, capacitor and
Resistor.
Inductor is not. Resistor is not relevant to capacitor. Regardless of the frequency, no? Resistor is not relevant to frequency. No? Regardless of the frequency of the signal, padadaanin niya ng resistor. Unlike with capacitor and inductor. Kasi meron niyang capacitive reactance and inductive reactance. Pinsan ni resistance. Bakit ko sinabing pinsan ni resistance? Because reactance also limits the flow of current. Yun nga lang, relevant sa frequency ng signal. Are you with me? Ma'am, bakit naging relevant sa frequency ng signal? Because capacitive reactance is equal to 1 over 2 pi SC. S. Diba? Mababang frequency, mataas sa capacitive reactance. Mataas sa frequency, mababang capacitive reactance. So as with inductive reactance, yan naman po ay 2 pi SL. Are you with me, guys? So, the manner of capacitor and inductor, its manner of limiting the flow of current through its terminals, guys, is relevant to frequency. Nakakasunod po ba?
Yes po.
Okay, so yun po. No, these are just few of those. No, these are the three very significant parts po of our transmitter. Now, pupunta tayo kay receiver. Si channel kasi could be made up of coax, fiber optics, diba, air, water is also a channel for information. So, sa receiving part, ang mauuna dito, guys, amplifier. Bakit amplifier yung mauuna? Galing sa biyahe. Kung ikaw ba, galing kang biyahe. Manila to Baguio, pagod ka na. Napagod ka kakatulog. Makarating ng Baguio, diba? So, anong gagawin mo muna bago ka mamasyal? Kakain ka muna, diba? Para to gain strength. Tama po ba? Yes, kakain muna. Okay, so ganun din po yung signal natin. Bago po siya i-process, i-amplify po muna. Kasi pag hindi mo in-amplify yan, tapos pinrocess mo, mamamatay yung signal. Kasi masyado nang deteriorated yung amplitude niya. Okay? So, kasi parang ganito. If our information is 1, tapos yung carrier signal natin ay 2. So, therefore, meron tayong 3. Yung 3 na yan yung aandar. Yan yung ipapasa. So, marireceive niya 3. Hello po. So, di ba sa receiver, kailangan makuha natin yung original information, which is 1. So, si local oscillator po, after the amplifier, meron tayong local oscillator din. Ito si local oscillator natin ay katulad ng local oscillator ni transmitter. Kasi ang ipoproduce niya ay 2 para makuha yung 1 doon sa na-receive na 3. Sinimplify ko lang guys pero hindi talaga 1, 2, 3 yung ano doon, no? Nakukuha po ba natin? Sinimplify ko lang. Pupunta po tayo dyan sa modulation and demodulation po na computation ang atake po natin. Okay? So that's the manner of communication system in its simplest explanation. Any question po before we go to the next slide? Walang question. If there's no question, pa-heart react nga po. O kaya pa-type na lang, none. Kasi hindi ko makikita lahat kung nag-heart react eh. Please type none. If you have no question, type none. Para magising naman tayo dyan. Okay. So let's proceed with our next slide. So our next slide actually, no, nabanggit ko na to. Defines the transmitter and identifies what comprises the transmitter. Ito po yung communication channel natin, and then the receiver. And then transceivers, no? Ayan. So transceiver, this is a system that is capable of transmitting and receiving at the same time. Can transmit and receive yan. Telephone yan. Yan pong mga examples na yan. Okay, noise is a random, undesirable electronic energy that enters the communication system via the communicating medium and interferes with the transmitted message. Guys, kasi po, si noise, ang tinitira talaga ni noise or ang sinisira niya talaga ay amplitude. Ito po talaga. Okay? Ang analog signal po natin, sa bawat point, no, of voltage, netong signal natin na to, may information na nakasakay dyan. So kapag may noise na sinira yung amplitude, distorted na yung information natin. Tama po ba? Distorted na yung information natin. Kaya nga po nag-come up into digital. Diba? Kaya nag-come up into digital communication. Kasi nga po, this is bridging the gap. Problem yun eh. Diba? The analog communication has bridged the gap of distance. Kaya lang, may problema pa rin. So, anong ginawa? In-enhance. Meron ng bridging, in-enhance na lang. Okay, and noise degrades and interferes with transmitted information. Okay, next slide. Signal attenuation. So, magkakaroon ng attenuation if the noise has already affected the amplitude of the signal. So, we have types of electronic communication. One-way, two-way, one-way or two-way transmission. Guys, an example of a one-way communication is yung binigay nyo rin kanina, broadcasting. Diba? Di naman kayo, halimbawa, nanonood kayo ng paborito niyo si Choco Martin. Diba? Tapos, pangit yung reception, scratchy. So, wala naman kayong kahit gano'n pa ka-smart yung TV ninyo, hindi naman kayo para mag-chat. Using your smart TV, papunta sa channel 5 ba yan? Okay, para sabihin na pangit yung reception o ayaw niyo yung kwento na nangyayari dun sa Batang Quiapo. Tama po ba? Hello po, walang ganon, right? So there's no exchange. Nagbabato lang. Are you with me? So that's one way. That's a one-way type of electronic communication. Tawag po natin dyan ay simplex. Okay? Sa two-way naman, meron tayong full duplex or half duplex. Okay, doon muna tayo sa half duplex. Alam niyo yung walkie-talkie or two-way radio? Hello guys? Alam niyo yan. Pinilit no? Kung hindi man, pakisearch nyo na lang sa Google kung ano itsura niya. Pero two-way radio po siya sa mga police, sa mga guard. Nakikita ninyo yung parang meron silang hawak na ganyan na may mahabang antena. Ayan, two-way radio po yan. Okay, ano yung principle niyan? if you want to transmit, no, if you want to communicate, you have to, may ipe-press ka doon para makapag-transmit ka ng signal. At habang nagtatransmit ka ng signal, hindi ka makaka-receive ng signal. Kaya hindi ka makaka-receive ng signal. So if you want to receive signal, i-release mo yung button na yan, and then saka ka makaka-receive ng signal, hindi ka naman makakapag-transmit ng signal. Naintindihan? So kaya po siya ni-label as half duplex kasi you can transmit naman and receive, pero not at the same time. Nakukuha po ba natin? Unlike with full duplex, ayan, unlike with full duplex, eto na guys yung ano, talagang pwede kayo magsabayang bigkas ng boyfriend nyo, kaya ng girlfriend nyo pag magkaaway kayo. Diba? Tama ba? Yan. Sabayang bigkas kayo, full duplex, sabay kayo magsalita, sabay kayo nakikinig, yan. Full duplex yan. Ibig sabihin, yan yung telephony. Okay? Ang next natin dyan, ito po, ang next natin ay analog or digital. Ayan. So, ito na. Ano nga ba ang difference ng analog sa digital? Pag analog, the signal varies with respect to time. Pag digital, meron tayong reference line. Okay? Meron tayong reference. As long as it's above, it's logic 1. As long as it's below, it's logic 0. Are you with me? Guys? Hello. Okay, so ano yung advantage? Sabi natin yung noise, diba? Ang ina-affect niya is the amplitude. Okay? For example, ito yung information natin, analog information. Tinamaan ng noise, bumagyo. Kaya wala kaming internet hanggang ngayon. Yung converge na yan talaga, oo. Ayan. Nalala ko na naman. O, ayan, diba? So, sobrang erratic. Erratic na yung ating signal. Tinamaan ng noise. Eh, di ba sabi natin, each point, no? Each point in this analog signal ay may information. So, wala na yung information na nandun. Unlike with digital, guys, kahit tamaan niya yan. As long as hindi lumalagpas, are you with me? Well, hindi mo masasabi na erratic. Why? Kasi, yung matitirang ganyan, na mukha na siyang silang ngipin, ay above the reference line pa rin. Logic 1 pa rin po siya. Naintindihan po ba? Logic 1 pa rin po siya. Eto, kung hindi naman lalagpas dun yung pagkatama ng noise sa kanya, logic 0 pa rin siya. Naintindihan po ba? Ang gagawin lang dito, sa digital signal na tinamaan ng noise, is i-regenerate lang. Hindi i-amplify Sa digital signal, you don't amplify, you regenerate. Anong ibig sabihin? Aalisin yung sira. Papatagin. Okay, nakuha po natin? Okay, kasi by the way, no, sa digital signal, hindi per bit ay merong carry na information. Unlike with analog, per point, no, per amplitude may carry na information. Dito hindi. How do you convert ba? You get a sample, halimbawa, 1 volt yung sample mo. Converted siya into 001010001. Ayan, so yan yun. So pag pinresent mo siya, 001010001. Ganyan po. Okay? Ito po yung analog na kinonvert mo to digital. Naintindihan po ba? Okay, I hope so. So that is the difference between analog and digital. Next po is the baseband and modulated signal. So again, yung baseband po, yan po yung ating original signal. Yan po yung ating information. Si modulated, yan na po yung ano guys. Yan na po yung either AM or FM. So let me explain further. Okay, so sa modulated signal, so may baseband tayo. Di ba may carrier signal tayo guys? Sabi natin kanina, sasakay yung modulating signal natin, yung information natin kay carrier. Ito si SLC. Okay, dalawa yan, AM. Okay, so ang mangyayari po, yung converted signal or modulated signal ng AM, it will carry the frequency of the carrier signal, but the amplitude will be varied by the modulating signal. Will be varied by the modulating signal. Okay, so anong resulta nun? Ang resulta po niya pa ganyan. Yan. So, ganun. No, yun yung AM. Now, sa FM naman po, okay, constant pa rin this time, constant ang amplitude. So, sa AM, constant yung frequency, varying amplitude. Sa FM, constant ang amplitude, varying ang frequency. Okay? So, habang pa-reach ng positive peak, mabilis po yung ating frequency. Habang pa-reach niya yung negative peak, bumabagal po yung ating frequency. Tapos, papunta na naman siya sa positive peak. Tapos, papunta na naman siya sa negative peak. Nakukuha po ba, guys? Hello po? So, yan po yung difference ng analog modulation and frequency modulation. Guys, don't worry. Pupunta pa tayo dyan ng more detailed with computation. Ayan. So, para lang hindi na bago sa inyo pagdating natin sa part na yan. Okay, next. Ayan. Ito na-discuss na natin itong one-way, two-way, no? Okay na tayo dito. Half duplex, full duplex, analog signal, digital signal. Ito po yung pinakita ko rin kanina. Yung baseband signal, digital signal, modulated signal. Ayan, modulation. So, may carrier tayo. Ayan. So, broadband siya kapag after yung baseband, yan yung information. Once you have modulated it, broadband na siya. Ba't siya tinawag na broadband? Kasi pwede na siyang mag-travel through the atmosphere. Kung makaka-travel na yung information natin in a longer distances. So, here is the black diagram lang po. Yung microphone, amplifier, modulator, blah, blah. Multiplexing naman, guys, is a process of allowing two or more signals to share the same medium or channel. So, para mas maintindihan, ito po yung ating, ayan, multiple information, one channel. A very good example of this is fiber optics line. So, si fiber optics, no, many information utilizing one channel. So, modulation and multiplexing are electronic techniques for transmitting information efficiently from one place to another. Ayan. So, electromagnetic signal, frequency and wavelength. Yan na po yung pinag-usapan natin kanina. Ito po yung wavelength na pinakita ko na rin po sa inyo earlier. Okay, so we have here, when we say wavelength, no, one cycle po siya. Either you start from positive alteration to negative alteration, so that's one cycle. Positive to positive, that's one cycle. Okay, so guys, electromagnetic signal is not just composed of electric signal or magnetic signal. It's a combination. Kaya tinawag siya na electromagnetic signal. And they are normal to each other. Ang ibig sabihin ng normal, perpendicular to each other. Okay, so itong blue, yan yung magnetic field natin. Itong red natin, yan yung electric field natin. Okay, so again, electromagnetic spectrum is the range of electromagnetic signals encompassing all frequencies. So guys, kapareho lang din po ito nung nauna nating diniscuss. Ito po yung ating electromagnetic spectrum. Ito yung usage. Yan. So hindi ko na babalikan, na-discuss na natin. So we have this optical spectrum, we have infrared, visible spectrum, and ultraviolet. So si infrared, we usually use this, guys, sa remote control, diba? Sa guidance and weapon systems, yung sa target, diba? Yung napapanood natin na biglang may red dot. Diba? Yung may red dot kasi yun yung target, mga ganyan. So si visible spectrum naman is used for we refer to as light. So, yan yung light natin. And then, ultraviolet for medical purposes. Ultrasound, o kaya yung yung ipinapasok sa, di ba ngayon, uso ngayon, hindi na para biyakin pag ooperahan kung kaya nung, that's strostoscopy. Parang gano'n. Yung medical technology na yan. Okay, and then bandwidth, from the word band, width, so width is kapal. This is the range of frequency kung saan pwedeng makadaan. So we have the lower frequency and upper frequency. So para ma-identify natin yung bandwidth, halimbawa yung extremely low frequency, 3 Hz to 3 kHz. So bandwidth is upper frequency minus lower frequency. So that's 3 kHz minus 3 Hz. So this is equal to 2,997 Hz. Yan. So yan yung width kung saan ganito karaming klase ng frequency ang meron po inside the extremely low frequency band. Okay, yun. Channel bandwidth, yun din po yun. Okay? So there is tremendous competition for these frequencies between companies, individuals, and government services, in individual carriers, and between the different nations of the world. Okay, guys. It is NTC, no, sa Pilipinas, National Telecommunications Commission po, ang nagbibigay ng karapatan sa isang company or sa isang entity para gamitin yung certain frequency. Like for example, sa FM natin, guys. Okay, yung isang channel lang, halimbawa 97.1. Okay, hindi yan basta, akin yung 97.1, sakupan ng lupa, hindi gano'n, no? So, they ask for a registration sa NTC. So, si 97.1, I don't know kung nagra-radyo pa po kayo, yung 97.1 na yan, ano po yan? Yan yung mid-frequency. So, meron po talagang bandwidth. Na kung saan, dyan nag-ooperate yung channel na 97.1. Kaya minsan, di ba, I don't know kung meron pa po kayo na radyo na denob, minsan, o kaya kahit digital mas nakukuha mo yung magandang signal, magandang reception sa 97.5, pero 97.1 yon. Pero habang ina-adjust mo, 97.5 o kaya 96.95, ganyan. Pero 97.1, kasi nga po, hindi naman 97.1 lang talaga. Meron siyang certain range. No? May bandwidth na tinatawag. And so as with AM. And so as with TV channels. Pero yung 247, hindi 2 megahertz, hindi po. In-identify lang po yung channel 2 na yan, pero may certain range of frequency na ginagamit sa channel 2. Same as with telecommunication. Iba yung frequency band na ibinigay kay Globe. Iba yung frequency band na ibinigay kay Smart, and so on and so forth. Naintindihan po ba? Hello po, naiintindihan po ba natin yung sinasabi ni ma'am na magkaiba ng band? Kaya nga po yung, di ba para, minsan tinatanong natin, ano bang network yung 0905, 0915? Di ba guys? Kasi that pertains to the range of frequency allotted, either Globe or Smart or Sun or Talk and Text and all. Ayan. Okay? Ayan. So the electromagnetic spectrum is one of our most precious natural resources. And this is actually our last slide, not necessarily, though we have spectrum management. So sabi ko nga, sa spectrum management, yan po. Kung sa ibang bansa may FCC, sa atin po ay merong NTC. So that's the end of the presentation. Again, I'll be giving you a copy of that. I-upload ko po yan sa ating MSC. Ayan. So I hope everyone was really listening at meron po tayong natutunan sa 66 slides na pinresent ni ma'am. And yan po yung reason kung bakit mas gusto ko po na face-to-face tayo kasi talagang pupunuin po natin ng discussion po yung ating, hindi naman CRs, mga 2.5, ganyan. Okay, so again guys, next Saturday, face-to-face tayo, and another Saturday, face-to-face tayo, kung titingnan natin ang kalendaryo. 14 and 21, October 14 and October 21, tayo po ay face-to-face. So yung October 28, sakto, dahil paundas na po yan, malamang mag-uwian po kayo ng probinsya, yan po, mag-asynchronous po tayo dyan. Okay po ba yon? Diba? At least sumakto pala yung schedule ko ng face-to-face. Ayan. So, ganun po yung gagawin natin. Okay? What else? May question po ba kayo? Wala. Next meeting po, magdala po kayo ng what do you call this, ng 1/4 index card and 1x1 picture whole body. Whole body na 1x1, ha? Hindi. Siyempre hindi. So, 1x1 picture. May friends ba kayo dun sa 3-1? Section na 3-1? Para, ano lang. Saan ko ba? Dito naman. Ay. Okay, so para saan po yung ano? Nakikita po ba? Okay, so ito po yung index card. 1/4 index card. Dito po yung 1 by 1 picture natin. Dito po yung subject and section natin. Ano ba yan? ECEN 2008334. Ganyan na lang. Tapos, schedule natin Saturday, 10:30 to 1:30. Tapos dito, last name, first name, middle initial. And then, 3 boxes para sa absences. 3 absences po before midterm would mean drop. Tapos pangalan ko po dito sa baba, Engineer Meldanet Bayani. Ayan po. Tapos, ano po, gagamitin ko to for attendance, for recitation, for board work. Ayan po. Pag walang nagre-react yan, mag-i-index card tayo. Yung kahit hindi mo pangalan mo pa rin yung tatawagin ko. Dahil ako lang nakakakita ng index card. Kidding aside kayo. So, yon. Kailangan meron na po kayo niya next meeting. White index card lang po Huwag po tayong gagamit ng pink, yellow, purple, green. So, masaya ang makulay pero let's be more formal po sa ating index card. Ayun. Okay? Ang room po natin ay 308. Tama po ba? Oo. Aircon ba yon?
Yes po, ma'am. Dalawa po yung aircon door.
Ayun. Okay. At least hindi tayo maging emotional. Diba? Mahirap maging emotional. Tapos 3 hours yung klase natin. Ako talaga yung magiging emotional doon dahil ako yung nakatayo at nagkaklase. So anyway, 12:48, 11. So okay na ba yun guys? Na nag-start tayo mga 11 and we'll end up by 12:48. Okay, so let's make use of our time. Mas maraming time next meeting pag face-to-face na po tayo. Okay, so that would be all for now guys. I'll see you next week po. Please, face-to-face po tayo next week ha. Unless talaga magkaroon ng suspension dahil may bagyo pero hindi uulan. Okay, so see you guys next Saturday. Bye guys.
Bye, ma'am.
Thank you po.
Thank you po. Thank you po, ma'am.
Thank you po, ma'am.
Thank you, ma'am.